Welcome back. This is Nick Egram. I will be discussing in this video arc length and sector area. As you can see here, the figure that I pasted here is specified what is a sector. A sector is formed when you divide a circle into different pieces, and between two radius or between two radii, then we have a sector, and the area that is formed, that is called a sector, and the length between the first radius and to the second radius, it's called the arc. And in here it is represented by L, but I'm going to use the word arc L, arc length here. This is a simplified between A to B, as you can see here, the red line here from A to B. Then you have the L, that is our arc length, and in between them the white, if I'm going to put green there once again here, that is our sector area or the sector. And we can find the arc length by deducing or giving a giving a pattern. For example, a whole area, a circle I should say, the circumference of that is 2 pi r. And if we have a semicircle, and if we are only interested to find that this length from A to B, just the length, the curve length, and it will become the semicircle or half circle, then we have 2 pi r divided by 2. And then if we have a 1/4 circle, then we have C 1/4. The circumference of that is 2 pi r divided by 4. So if we think about degrees now, this is actually 360 degrees multiplied by 2 pi r divided by 360 degrees. That's why we got only this one. But when we have a half, then we have 180 degrees multiplied by 2 pi r divided by 360 degrees. That's why we got only pi r actually here, as you can see there. And then here you have 90 multiplied by 2 pi r divided by 360 degrees, and this is actually pi r divided by 2. This is now pi r divided by 2 also. That this is 180. Now in any arc length, now if we generalize now what we have discussed, we have now arc length is equal to, we have the theta. You see that I used degrees here, theta multiplied by 2 pi r divided by 360 degrees. Or we have theta multiplied by pi r divided by 180 degrees. Okay, this is for the measurement in degree. How about in radian? So we have arc length for radian. We have theta multiplied by 2 pi r divided by 360 is 2 pi. Then we have, this will become 1, then we have theta multiplied by the radius. So arc length is in radian measure. We have radian here is equal to theta multiplied by the radius. Whereas in degree, we have theta multiplied by pi r divided by 180. So it depends what is the given in the problem. Now we're going to sector area. This area now, the pink one or the red one. Pink maybe, I don't know. Okay. For the whole circle, once again, we'll go back there again. For the whole circle, the area for that is equal to pi r squared. If we have a half circle or semicircle, the area of that is pi r squared divided by 2. If we have 1/4, then we have area for that is pi r squared divided by 4. But if we're going to expand this with respects to theta, then we have 360 divided by 360 multiplied by pi r squared. And this one is 180 degrees divided by 360 multiplied by pi r squared. And this one is 90 divided by 360 multiplied by pi r squared. So in any, the area of any sector is with C, not with K. Sector, that is, we have theta divided by 360 multiplied by pi r squared. This is again in degree measure. How about in area of a sector, C, in a radian measure? Then we have theta divided by 360 is equivalent to 2 pi multiplied by pi r squared. Then pi will become 1. Then we have theta multiplied by r squared divided by 2. It's good to remember the formula, but it's good to remember how they come from, where they are come from. Okay? So, okay, I think I stopped there, and thank you for watching, and I hope you learned something, how to derive the sector area and the arc length. And in my next video, I will be discussing different examples on how to use those formulas that we derive. Okay, see you there. Have a nice day.